very much look forward to getting into some of the deeper details, the where the rubber meets the road, where the real opportunity is, where the real use cases are. I'll speak both from perspective of my role at Microsoft, where I do what we call healthcare partner enablement. So a partner to us provides solutions, services, or both to customers. I happen to focus 100% in healthcare, covering provider side, payers, pharmaceutical, life sciences worldwide. But we do all industries essentially. So blockchain is one of the things that runs in the cloud, but alongside AI. That's one of the interesting things about blockchain. It's not, a lot of people when they first look at it, they think of it as blockchain is a new solution that's going to replace other stuff, right? And actually in most cases, it's going to coexist with enterprise systems. It's going to take the role of a B2B middleware. And it coexists with a lot of infrastructure. You've got message queues on the front end to batch transactions onto blocks. You've got databases on the back end to facilitate rapid search and discovery of information on the shared ledger, et cetera. So an AI which can run on top of that. There's some very interesting stuff at the intersection of blockchain and AI. I won't have the ability to go deep into that today, but I do a lot of sort of research and speaking on that particular topic. So if you're interested in that, we can always chat afterwards. Let's go forward. So the way we look at blockchain is really three facets. We've got the cryptocurrencies and crypto tokens. You guys know about Bitcoin and Ethereum and all that good stuff. We know about ICOs and fundraising. What I'm really going to focus on here is the third facet, which is enterprise use cases and values. So an enterprise, why would businesses use blockchain to collaborate? And what are the values that they seek? Like, how does blockchain add value over the way they do things today? In healthcare, we have a lot of faxing still going on. We have a lot of emailing and just phone calling, and even the health information exchanges are sort of older sort of central hub and spoke architectures that add delay, they add cost, they add single points of failure, and blockchain can add value in those kinds of circumstances. So there's a lot of cases where you have consortia. So blockchain first and foremost, when we get an idea come to us about blockchain, one of the first things we ask is, what is the consortium? What is the network of organizations that's going to collaborate with blockchain? And if the first thing that comes out is, well, it's just one organization, we're going to use blockchain internally, usually that's not a good use. I mean, there are corner cases where you may have a very large company that has lots of sort of divisions and they have a lot of siloing and lack of exchange of data, and maybe blockchain can help in that case. But most often the litmus test for blockchain is, what is the consortium? And then what is the use case? And what is the business value that's going to drive that consortium to want to transact using blockchain, right? Not because it's cool, not because it's new, not because it's disruptive, but because it's going to reduce cost, or in healthcare, because it's going to improve the patient outcomes, or it's going to improve engagement of patients, compliance with treatment plans, or it's going to improve their experience. So those are the kinds of business values. I'm going to try to keep this as general, enterprise-focused, cross-industry as possible, but forgive me if I give a few healthcare examples. That's where I do most of my work. And we all know about the inefficiencies in healthcare and opportunity for innovation, but we really look at blockchain as a set of layers. So layer 0, we know today there's a lot of data in silos, right? We've got a sort of mindset of, let me collect as much data as I can and hoard it in my silo, because that's a stickiness, that's how my business differentiates, et cetera. And really the opportunity with blockchain in layer 1 is, blockchain can really enable the secure targeted sharing of some of that data where it makes business sense. So blockchain is not going to replace databases. Databases will continue to exist. Silos will continue to exist. There's reasons that some of that data is siloed. Some of that data is differentiating. It's super sensitive. It's sensitive intellectual property. It's what we call PII, or personally identifiable information, or it's PHI, protected healthcare information. But a lot of the data in those silos is not differentiating. And companies spend a lot of money to maintain that data independently. So for example, anybody that's changed phone numbers recently or changed addresses recently, you got to go to like hundreds of websites and update all that information. It takes a long time, and there's a lot of websites you never get to, right? And that results in a lot of inefficiencies, people trying to mail you at the wrong address, et cetera. And one of the biggest problems is we all know healthcare is really expensive, right? One of the things that drives up the cost of healthcare is you've got all of your patient data is around in all of these silos, and guess what? Every single healthcare organization you visit has to maintain that information independently. It's not that they have to store it, because storage is cheap. It's that they have to maintain it. They have to collect it. They have to update it. They have to manage it, secure it to prevent breaches, all that. That all adds costs. So it adds n times the cost. What if that common data that isn't differentiating could be on blockchain and could be maintained at 1 times the cost? So if there's an update, it ripples across the consortium near real time. You would cut cost, and you would also cut out inconsistencies in that common data across the consortium. Those inconsistencies today result in a lot of friction. So in healthcare, if the payer has different information from the provider and a claim is sent, oftentimes that claim will be denied. It'll bounce because the data doesn't match up, right? And when a claim bounces, people don't get paid. And humans have to fix that. And so there's a lot of extra cost, a lot of extra delay, a lot of extra friction, and so forth. So that's the opportunity in layer 1 now. Layer 2 is blockchain is not just a vehicle for exchanging data. It can actually automate. We know about smart contracts, right? Smart contracts is a lot of different flavors, but Solidity is one of the more common smart contract languages. And we know that Solidity is Turing complete. So you can essentially do all kinds of business logic on smart contracts. But think of in layer 1, what we've got is we've got blockchain as this B2B middleware sitting in the middle of this consortium, and data is being exchanged. But all of the compute, all of the execution is on the periphery. It's in the enterprise systems that are connecting to the blockchain. What smart contracts give us the ability to do in layer 2 is do some of that executable code on the actual blockchain. So for example, a lot of times if, say, a claim needs to be processed, the logic that processes like 80% of claims is quite straightforward and simple. There's always corner cases that are really complex and need to be processed in enterprise systems. But a lot of cases, the logic is fairly straightforward for 80% of the claims. If you can process them right on the blockchain and not depend on the leaf node, which is, by the way, a single point of failure, you can get much faster response. You can decentralize the compute, so more efficiency. You eliminate that single point of failure, et cetera. So that's the opportunity with smart contracts. Layer 3 is cryptocurrencies and tokens. And so I said at the outset that the 3 facets, I wasn't going to focus on cryptocurrencies and tokens. But it turns out there's actually an intersection between cryptocurrencies and crypto tokens and enterprise blockchain. I'll give you an example. One of the things that healthcare really seeks to do is engage patients, right? So that they are willing to give consent or opt in to sharing their data for things like clinical research. And they like patients to comply with their treatment plans. If the doctor says, please take this medicine, do this, do that, the better they comply, usually the better the outcome for the patient. Generally, the compliance is not very good with medications or treatment plans. And oftentimes patients won't opt in or participate, they're just not interested. What if we could use cryptocurrencies and tokens to incentivize patients to comply with their treatment plan, incentivize them to participate in clinical research, and reward them with cryptocurrencies and crypto tokens, things they can then redeem for value? There's a fantastic opportunity to incent collaboration, to incent sharing across these enterprise consortia with blockchain, and that's layer 3. Now layer 4, artificial intelligence and machine learning, there's fantastic opportunities at the intersection of AI and blockchain. Think of it this way, as blockchain is, or rather AI and machine learning, we know they're super data hungry, right? And one of the key things that stunts a lot of AI initiatives is a lack of available data. And the reason is they're drawing that data out of one organization, out of one silo. And there's a limit to how much data they have, right? And if you're talking about training advanced models or specialized models, you might need hundreds of thousands or millions of records, right? And you run out, especially if you're doing a specialized model. So the opportunity with blockchain is, what if you could incentivize the sharing and collaboration across the consortium? All of a sudden you can draw data from across the consortium. You can get provenance information of data across the consortium. You could collaborate on shared models, right? Shared models. You might even be able to pass those models around each organization. So each organization trains those models incrementally right? Because sometimes the impediment is each organization in the consortium can't actually physically share the data. They haven't got the consent to do that. But if you pass them a model and say, just train this shared model on that data, and then pass it on to the next organization, you can end up with a shared model without actually sharing the raw data. So collaboration on shared models, on testing AI. How do we trust AI? If you come up with a new model in AI for diagnosing patients or helping radiologists or others diagnose patient conditions, how do you trust it? Well, you have to test it. You have to validate the test results. If you do that as one organization alone, it's going to take you a certain amount of time of testing and resources, right? But what if you could collaborate across the consortium and test that collaboratively? You could learn to trust that model a lot faster, right? By sharing test results, by sharing validations of test results. So that's the opportunity in layer 4. We're very much in layer 1, layer 0, layer 1 right now. There's not a lot of smart contracts or other stuff going on, but that's roughly where we are. Certainly in healthcare, but most industries are around that point. So blockchain, I'm not going to dwell too long here because you guys, a lot of you, I saw hands, you know blockchain well, but it's a chain of blocks, right? We got 3 blocks shown here. Each block is a hash code. The hash code is a hash of the data on that block plus the previous hash code, thus blockchain. There's a chain, right? And the thing that makes blockchain special is that it becomes impractical to modify that data. So it's got this property of immutability you might have heard. The fact that there's the hash codes, the chained hash codes, plus the decentralization really mitigates any risk of collusion and modification. So when you can learn to count on the immutability of the blockchain, that introduces some really interesting new capabilities to build trust across the organization, across the consortium, and each of the organizations in it. So the blockchain network is made up of these blockchain nodes. There's no central node, it's decentralized, right? But you've got these nodes, and each one sits on top of a copy of the shared ledger. And when a new block is added to the shared ledger, it replicates across the whole blockchain network, right? So the mandate of the blockchain node is to maintain the consistency and validity of the shared ledger. And so when something is added, it ripples across, so they all have a consistent shared ledger, and that makes up the blockchain decentralized network. So I've got a little diagram here. I kind of talked about this earlier. I'm showing 4 organizations, A through D. So think of these as enterprises, right? An enterprise consortium. And the green blocks inside are the enterprise systems. So in healthcare, on a provider, like a clinic or a hospital, they'll have an electronic health record system or a radiology or a lab system. A healthcare payer might have a system to maintain membership, eligibility, do claims adjudication, et cetera. But these enterprise systems can connect to the blockchain given a specific use case and specific value, business value. And they can do secure targeted sharing of data, right? And so think of blockchain as this B2B middleware. I think of it as a data superhighway, and the blockchain nodes are the on-ramps and off-ramps. So for organization C, that node is their on-ramp and off-ramp to that blockchain superhighway. And so it enables them to add information to the shared ledger and review information in the shared ledger that was added by other elements of the consortium and drive business value through that. The most of what we're seeing for blockchain in the enterprise is private consortium use. What that means is organizations A through D are well known and highly trusted across that consortium. Then there's no sort of anonymity like you would find in a public blockchain. Most enterprises, certainly in healthcare or highly regulated industries like financial services, they're opting for private consortium blockchain because you have regulations, data protection laws, et cetera, that require only authorized access to data. So for example, HIPAA in healthcare requires only authorized access to healthcare data, or PHI, protected healthcare information. And so they can't just put that on a public blockchain where anybody in any part of the world can access it, right? That's one of the reasons they're gravitating to private blockchains. Think of this as a blockchain island. And I'll talk a little bit at the end of this about the sort of evolution of blockchain, because a lot of times you get into this sort of religious discussion of public versus private. Is private really blockchain? And actually, we see a trajectory where a lot of organizations will start with private, but over time, those blockchain networks will grow and grow in terms of number of organizations participating. and they'll move on the spectrum from private towards public. I don't know if healthcare will ever be fully public blockchain. Maybe for certain use cases like CDC, World Health type, use cases. But if you're getting treatment here in the US, there's not many use cases in healthcare where your data needs to go to, say, Romania or something, right? So that's the blockchain in the enterprise consortium, not rocket science. Then think about the deployment of the blockchain nodes, right? Like, where do they run? And blockchain is kind of a foundational platform. So those nodes can run in a lot of different places. It's going to have a heterogeneous deployment architecture. Some of those nodes might run on-prem or on-premise, like in your DMZ of your organization, right? Some of them might run in the cloud. Certainly they can run in Microsoft Azure, but pretty much any cloud will run a blockchain node. And in a given sizable blockchain network, there'll be a mix of those. So some might be on-prem, some in cloud. The ones that are in cloud will be in different clouds. But in this diagram, you can kind of see how blockchain is really synergistic with the enterprise systems. Again, enterprise systems connecting to the blockchain. Blockchain is not replacing those enterprise systems. And then blockchain is also synergistic with a lot of different types of infrastructure. We've got message queues here on the front end. When you're putting transactions into blocks, you're going to have a message queue to batch those transactions up. Generally, you don't put one transaction per block because the block throughput rate in blockchain ends up being a constraint on performance. It's pretty common to have a blockchain throughput of, block throughput of like several hundred to maybe 1,000 blocks per second maximum you can put at the end of a blockchain. There are corner cases to that, but generally that's in the right ballpark. The problem is if you're talking to enterprise IT, they're used to like millions of transactions a second into databases, right? So how do you get up to millions of transactions a second? What you do is you batch transactions. So you take 1,000 transactions and put that on one block. That way you amp up the transaction throughput. There's a trade-off in latency there, but that's how message queues are synergistic with blockchain. Then you've got the thing about blockchain, a lot of people bang the drum of blockchain is decentralized, so it's very reliable, there's no single point of failure, and that is true. So if you take out a node of a blockchain, the remaining nodes will keep running. When the node you took out comes back up, it'll bring its shared ledger up to speed. So it's very resilient in that way. Unless you take down the entire blockchain network, some part of it will still run. The thing about blockchain is there's nothing special about blockchain that protects the reliability of a particular blockchain node. So if I'm an enterprise and I'm accessing the blockchain superhighway and I'm connecting my enterprise systems to a particular blockchain node and that node goes down, you've cut off my access to that blockchain network. So blockchain doesn't assert reliability for any particular blockchain node. It's just saying the network as a whole is resilient because there's no single point of failure. But if you are, say, in healthcare or whatever industry and you have a use case that's moving into production and it becomes mission critical for you, like if you get cut off from this blockchain network, you will stop doing business or patients' lives will be at stake. You've got to be thinking about how do I protect the availability of my blockchain node? And so you can use well-known and well-established and proven tools like having redundant nodes across availability zones and having load balancing, automated failover, and using backup and restore, and business continuity and disaster recovery, et cetera. So we know these tools, and we just need to apply them. Blockchain is not something special. It can also use those tools. So this is just going over the use case of, here we have like a situation today that we see in so many industries where we have organization A through C, and there's a silo of data in each of those organizations, and within that silo we have some common data. And then there's some private data. And the common data generally is not differentiating, right? Everybody has it. Patients don't go to you just because you have, like I'm not going to go to a clinic just because they have my address, right? I mean, it's easy to just give it to any of them, right? So this common data, the acquisition and maintenance of this data becomes a cost for the organizations. It's not a differentiator, right? Today that cost is n times what it would be with blockchain. If you move that common data, not the private data, some of the data is sensitive and it's differentiating and they're not going to publish it anywhere. But the common data that's non-differentiating, what if you put that on the blockchain? And then if any one of those organizations updates it, it immediately ripples across the whole consortium, and you eliminate that redundant maintenance cost. You eliminate inconsistency because any changes replicate near real time. That's really one of those sweet spots. There are other business drivers for using blockchain, but like anti-fraud and so on, but that's one of the key business opportunities. So in many cases, I think blockchain was a missing cog in information technology. There's all these organizations, whatever industry you pick, these organizations have advanced IT within each of their intranets, and they're collecting a lot of data. What's missing is the ability to do secure, targeted sharing of that information in a way that builds trust and facilitates automation with smart contracts and so forth. We often, when we talk about blockchain at the end, is inevitably somebody comes up and says, well, that's a nice use case. I see the business value, but why not do it with a database or whatever technology, right? And what's particularly interesting to me is to hear how consortia of enterprises respond to that question. And some of the common responses I get are, if you have a consortium of organizations and you need to share some data, you got to put that data somewhere, right? If you put it in one of the organizations, there's an unfairness problem, right? All the other organizations think, well, why should I pile all my data into that one? What if they run with it? And so there's a fairness problem with doing that. The other option is, let's put it in a new central organization that will maintain it and everybody can work with them, right? Well, does that organization already exist? What do they charge? What's the delay? Are they a single point of failure? If it's a new entity you're going to stand up, there's a huge amount of extra cost there, right, to establish a new central hub. And so, other answers to this question are, if it could have been done by a database, why hasn't it? Databases have been around for decades, right? You see the use case, you see the business value, yet it hasn't been done. Why is that? So blockchain has some unique new characteristics. Immutability is one, the resilience is another one, that pave the way for facilitating the secure targeted sharing of data where it makes business sense. And so that where it makes business sense is super important. And I keep hitting that because what we strongly discourage is enterprises that get into blockchain, that understand it, they drink the Kool-Aid, they get excited about it, taking the approach of, let's put a bunch of data on blockchain and we'll figure out later how to use it, right? That's not the recommended approach. The better approach we've found through a lot of experience is define the use case. What are you doing with blockchain? Are you sharing healthcare data? Are you facilitating credentialing of nurses and doctors, or whatever your use case is? Define the use case. Define the business value. Why would the organizations in the consortium do this? Are they doing it to reduce cost or what? That's super important to get the buy-in later on. But then given the use case, what is the minimum but sufficient data to put on the blockchain? And when I say minimum but sufficient, literally field by field, why do we need this field on the blockchain? If you don't need it on the blockchain, leave it in the enterprise systems, right? So very frugal, minimal but sufficient approach. Only what has to be on blockchain goes on blockchain. That's for several reasons. It's for performance reasons, and it's for privacy, security, and compliance reasons. If possible, keep the personally identifiable information off of the blockchain. If possible, keep the protected healthcare information off of the blockchain. Keep your sensitive IP off of the blockchain. So think of blockchain as this cog in the big machine. If I say don't put personally identifiable information on the blockchain, you might say, well, how can it be useful? You're not identifying anything useful, right? And so the key is you can use, sensitive personally identifiable information is things like your social security number, your date of birth, your contact information, address information, location information. That's the kind of stuff you generally don't want to put on blockchain. And but what you could put on blockchain is an opaque identifier for that patient, a long alphanumeric string that if it got breached, it's useless outside of that blockchain. To make any use of it, you've got to resolve it to the PII. And the actual personally identifiable information can live in the enterprise systems on the periphery of the blockchain. So collectively, the big machine comprising of the enterprise systems plus the blockchain can resolve the patient personally identifiable information, but you don't need to put all of that information on the blockchain. Again, blockchain is the one cog in the big machine. It's not the only place you store information. Yeah, go ahead. Question.
So I agree with what you're saying, right? One thing that I always think is I'm a big fan that self-sovereign data and data should be a human right and all that kind of stuff, right?
Decentralized identity.
When you think about it, like you just say like, don't put data on the blockchain, right? But hey, don't put it in Equifax or Facebook or Google either, right? Because we have kind of seen what happens, how open the data is, because there's no incentives to create security in a world of free services. So also when it comes to health data, when I look at some of these insurance companies running their COBOL systems and so on, I would much rather have my data in my own personal data vault and now digitally sign and give them a public-private key thingy to access the data as they need it. And when if these companies were halfway smart, then they would actually say, hey, look, especially when you are like me from Germany, right? You don't want this data because it's actually a liability. And if you try to become Facebook, then you've already lost as an insurance company or healthcare provider, right?
Yes.
So
that's a great.
Blockchain technologies is a good way to push data actually and give people responsibility and ownership or control over their data, right? Because once we create new ethical standards and also legal frameworks, that also creates friction for the platforms that hopefully dries up that swamp.
Yeah, excellent points. How many people are familiar with decentralized identity or self-sovereign identity? I see probably about half. So really interesting points. Thank you for sharing that. And so absolutely, wallets, with PII maintained by the actual data subject could be one of the federated sort of storage vaults, if you will, of sensitive information. I think what we're going to see in the near term, and Microsoft does a ton of work in decentralized identity, just search for it and you'll find it, but to give you a balanced response on that, I don't see it as a panacea. Decentralized identity will be excellent in terms of empowering the data subject with their data, and it will be a great tool for those data subjects that are savvy to take a minimal but sufficient approach. Like, I'm only giving the information to you that I need to give to you and no more. But I think what we're going to see is patients will have to give certain data to get certain services. And so I don't think healthcare in the near term, and there's probably regulatory reasons that require this, they won't service you unless you give them pretty much everything you're giving them on the form today. When you go into a doctor, you have to fill in that form, demographic information, et cetera. And if you don't give that to them, they'll deny you treatment. And so it's not going to be, oh, we have a wallet, it's secure, and we don't have any more leakage. What will happen is, as you engage services, they will require certain data. If you give them that data, you will get the service. If you don't give them that data, you will not get the service. And once you give them that data will go into their database, right? Just like it is today. And so, yet, I totally agree, putting the data subject in control and them taking a minimal but sufficient approach is the right way to go.
They also only need to verify that whatever did the patient bullshittery in the beginning. And that, So do they need to really store a lot of this data all the time? Yes, companies think of it as a way to control, right?
A stickiness,
I want to move my patient record, I don't have to try how that actually works.
Sometimes it's a mindset,
And also, I think, people always think, but who cares? Like, when it comes to data, most people say, people, like one guy one time told me, he said, we as a society have agreed that we are happy to give away our data because the value that we get from services is greater than the risk. And so when was that Paul happening? Because I kind of So I think, especially in the land of the free, I always wait for somebody to say, look, we need to educate the consumer that that they should have a right to this data and that they should be educated enough to take responsibility for it.
Yes. No, I completely agree, and this is very much on the forefront of blockchain. One of the really interesting things, I think, is, like, oftentimes people need to know, in order to give you a service, they need to know you're over 18, right? So what do? They say, what's your date of birth? And really, they don't have to know your date of birth. They just have to know that you're over 18. So tools like homomorphic encryption give us a way to, so for the patient to prove to them, cryptographically that they're over 18 without actually telling them their precise day, month, and year of birth, which is, it's part of the golden triangle. If you have that plus Social Security plus, other things, Social Security, date of birth, and what am I missing? The third one. Address. That's a golden triangle, and if you have that, you can be someone. You can steal their identity. But yeah, homomorphic encryption will give you a way to be even more minimalist. But it's I'm giving you a balanced response. It's not a panacea, and one of the points you made is very good. Is for self-sovereign identity and decentralized identity to really deliver value, the data subject has to be educated. Because if you take the smartphone example where you downloaded an app and it says, okay, I need all these permissions, either you accept or you don't get the app, people just click yes, right? And I get this free app, right? So to your point, a lot of people are selling their privacy without actually knowing what the real cost is under the hood. So in order for decentralized ID to deliver its full value, people have to be educated, and that's going to take some time. So blockchain strengths, data integrity, immutability. We talked about secure targeting or targeted sharing of business data where it makes sense. Transparency is another one. So think of anti-fraud. That's one of the big use cases for blockchain that I don't think gets enough discussion is with fraud, a lot of types of fraud can be boiled down to 3 attack vectors. Either fraudulent modification of transactions, fraudulent deletion of transactions, or fraudulent creation of new transactions. And the data integrity, the immutability of blockchain essentially blocks the fraudulent deletion or modification of transactions. Where the transparency of blockchain really helps is if somebody creates a fraudulent new transaction, like a fictitious new transaction for fraud, and it's put on blockchain, that ripples across the consortium near real time. So the probability of that being detected is much higher than if it was buried in some siloed database that only 3 people had access to and they were colluding to hide it, right? So transparency is another big strength of blockchain, an opportunity to drive value, especially for anti-fraud. Decentralization, resilience, we talked about the strength of the availability of the whole network, but how you have to protect your individual blockchain node, especially as the enterprise consortium is moving towards production use, and especially if the use case is mission critical. Anti-fraud we hit. So identifying use cases, it's all about the network of organizations. It's obviously an IT network thing, but it's also a business network thing, blockchain, first and foremost. Collaboration around shared data for business value, so improving efficiency, reducing costs is a big business value driver we see often. Improving the quality of data. In healthcare, when you go to a doctor, everybody has to fill out that form, and we've probably done that like 10 or 100 times each, right? And it gets so annoying that you don't necessarily fill out all the fields, and the ones you do, like somebody transcribes them incorrectly, so there's a big quality issue. And the data gets in and it's wrong, it can hurt your healthcare, right? I mean, they might do suboptimal healthcare if you don't tell them about a certain allergy or something. So blockchain can really improve quality, because if you could somehow enter that information once and review it anytime, update it anytime, and if you go to another healthcare facility, it's accessible, you don't have to refill out the forms, that can really improve quality. It can improve the quality of service and the patient outcomes. So enabling collaboration for mutual benefit, of course, reducing fraud, improving reliability. Now, the near-term opportunities with blockchain, because a lot of folks say, okay, this makes sense, but where do I get started? So you got to have the use case, right? But the other thing to think about is what is the existing consortium that is already transacting, albeit with an antiquated technology. Like in healthcare, we still have a lot of faxing happening, et cetera. And so if you have an existing network, so if you have a use case and they're doing some antiquated technology, that's low-hanging fruit, right? You can drop blockchain in there and say, this is the value you will get with blockchain. And guess what? You don't have to build that consortium. They already exist. They already transact with each other. They know the business value. You're just putting blockchain in place of some antiquated technology and driving value. On the flip side, if you take a novel new use case, and there's a lot of really interesting, fundamentally new use cases, And then you have to go and convince a consortium to rally around that use case, to buy in, take that leap of faith. Here's blockchain, you've never used it, but trust us, it's going to deliver this value. And you've never seen this value, but trust us, it's going to happen. That's a tall order, right? It's hard to do that. And the time horizon to realize value out of those revolutionary new use cases is probably years. Versus if you find an existing network, an existing consortium, they're not using blockchain, you can bring blockchain to add value, whether it's anti-fraud, reducing cost, et cetera, improving resilience, there's your low-hanging fruit. If you prove the value in that existing consortium, you've then got a foothold to grow, right? And once you've proven yourself, you've proven the business value with one use case, it's really easy to add other organizations to that consortium. So you're growing in terms of number of organizations connecting in, and you get a sort of network effect happening. The other thing is relatively easy once you've got a sort of critical mass in your consortium is add new use cases. If you start with a certain use case and prove its value, it's easy to add more use cases on top of that. And the more use cases you add, you end up further adding to the network effect where the more use cases, the more data, the more organizations, you get this kind of snowball effect where blockchain will take off. So these are some of the use cases in healthcare that we see. We provide a directory. So supply chain is a big family of use cases in healthcare. We've got drug supply chain, so your medications right from the pharmaceutical company through the distributor to the dispensary, like the pharmacy, and even the patients or the family caregivers or the pharmacist, at the end of that supply chain. We've got medical device supply chains. So whether it's a pacemaker or whether it's an infusion pump or an MRI machine, those have a supply chain too. And they have a lifetime throughout their use at a hospital. And some of them get resold into other healthcare facilities, and they end up having multiple life cycles. And so tracking those devices through the supply chain and delivering value with blockchain is a fantastic opportunity. And one of the interesting business values with medical devices specifically is if there's a recall today, the recall of a medical device can actually take up to a year. And if you have a faulty medical device in the field, every day could be a patient life. There could be patients dying. So if you can shorten that down and if there's a recall, identify exactly where those devices are that need to be recalled and do that in minutes or hours or even a day, something less than a year, that's fantastic value in terms of improving patient lives. The other interesting supply chain use case I came across in healthcare recently is biological tissue supply chains. So if you're participating in clinical trials and so on, and you give a biosample of some kind, there's a whole chain of custody thing and different handlers, transporters, et cetera, and tracking that through the supply chain can be a very important thing, not just for operational efficiency, but also the integrity of results. And often with supply chain, you get these, like in drug supply chain, sometimes the drugs are very perishable, like vaccines. And if they're not kept within a certain temperature range, they're not safe to use anymore. Or they can be benign, like they could be inactive if they've been too cold or too hot. So along with just tracking the location of things in the supply chain, sometimes you get this tracking of environmental factors throughout the supply chain. So what was the temperature at each point in the trajectory through the supply chain? Was it within safe bounds? These kinds of things become very interesting with food as well. That food you got, is it really organic? Did it really come from this place? Was it really not subjected to herbicides or pesticides? And tracking it through the supply chain, was it kept at correct temperatures if it's perishable, especially for like dairy and things like that? Wonderful opportunity for food recalls as well with blockchain, right? I think Walmart's piloting this with leafy greens. Is if they have like a spinach poisoning or something, they can look it up on the blockchain. Where did this come from? Figure out exactly what stores, exactly what units need to be pulled off the shelf, rather than eliminating billions of dollars of leafy greens just because they don't know, right? So these are some of the key use cases in healthcare, but you can see here on the columns, we've got the business values. Is it reducing cost or other values? it's a really good exercise to go through this in whatever industry you're in. If you're evaluating like a handful of use cases you might focus on, what are the business values, really chart those out. And then the next step is, what are the consortia? What are the existing groups of organizations that are doing this use case? Maybe sans blockchain. Or do you have to build a new consortium? Sometimes you have to build one, but you need to level set. Your runway needs to be larger, right? If you're a startup and you're touting a totally new use case, you got to convince people this is worth doing. That's going to take longer if it's totally new. So building the consortium, the buy-in, the trust, this is the Achilles heel of blockchain. There's lots of great ideas with blockchain, but where a lot of them fail is they don't build the consortium, they don't get the buy-in, they never get to really pilot it in a meaningful way, and so it sort of dies on the vine, right? So if you're doing blockchain, focus on your use case, your business value in the consortium from day one, and get to pilot as quickly as you can, right? You don't need 100 organizations to pilot a use case, but you do need 3, I would say, or at least 2 at the very bare minimum, right? I mean, it's kind of debatable whether you need blockchain with only 2, but have a minimum viable product, like a prototype of blockchain, minimum viable network, prove it out quickly in a pilot, publish a case study on the use case, the business value, what did you pilot, get the attestation of the organizations, the end users of the blockchain, get that attestation into your case study, publish it, and if you get that attestation and they're respectable organizations in their industry, you've got a wonderful foothold on which to convince new organizations to come on board in a phase 2 pilot or going to production, and it'll snowball from there. Security is something we often encounter. Often blockchain's touted as a sort of security silver bullet or a panacea. That should throw up a red flag if you get that. Like, why are you using blockchain? Oh, well, it's secure, right? Blockchain has certain strengths in security. We talked about integrity, immutability. We talked about availability. But for confidentiality, there's actually a fair amount you need to do with blockchain to mitigate risk. And one of them is be frugal about what you put on blockchain. Don't put everything on blockchain. Put only on blockchain what you need to put on blockchain given your use case, right? So that's the biggest lever you've got to pull. The other lever is who's connecting to the blockchain and who's going to see that information. If you have a private consortium and everybody's well-known and highly trusted, you're mitigating the risk of unauthorized access. That's a way to mitigate risk to confidentiality. Of course, there's encryption. There's lots of different kinds of encryption. Encryption's good, but it's not a silver bullet, right? Encryption fails. Why does it fail? Because people don't maintain their keys properly, right? And they write passwords down on sticky notes and all kinds of weird and wonderful things, right? And the other thing is blockchain, again, is this cog in this big central machine. And the blockchain hacks that have happened, they don't generally reveal, at least to date, no sort of fundamental flaw in blockchain. But where the attacks happen is at the edges, at the periphery of the blockchain. So the exchanges, the wallets, et cetera, that's where the attacks often happen, right? If you're an attacker, like a cyber attacker, if you can't actually attack the blockchain, what do? You attack what connects to the blockchain at the nodes, the enterprise systems, et cetera. Or you attack the end user. You do social engineering. You get them to give up their key somehow. So it's a multi-layered defense in-depth approach. Blockchain is not a panacea for security. There's other stuff you got to do on top. Pay attention to confidentiality. The other concept in security is a concept of adequacy. So when you're connecting an organization or a consortium of organizations to a blockchain, there's this notion of adequacy of security around the consortium. Because if you're an individual organization and you have a breach, that's on you, right? But if you connect to a blockchain and one of the other members of the blockchain consortium has a breach, that's going to affect them. It's going to affect the blockchain. It's going to affect the whole consortium, right? So you want to make sure that if you're sharing information on blockchain, that the organizations connecting and accessing that information first have a right to know, a need to know, a business need to know, and then secondly, that they are going to have adequate security to protect that information. Because remember, they're going to pull that information off the blockchain in some cases to read it, to put in their own enterprise systems, et cetera. So there's this notion of adequacy of security, and there's actually a wonderful opportunity for people in cybersecurity and compliance to offer their services to measure the security and compliance across the consortium, make those results available, those audit reports and security risk assessments available for the rest of the consortium to see. So it's a trust building mechanism. If a particular organization doesn't pass an audit or is found to be lacking in security, that's an opportunity for them to bolster their security, to bring themselves into compliance and help the rest of the consortium understand that, so that they don't become the weak point, the breach point, right? So this is key. A lot of folks aren't thinking about the adequacy of security across the consortium. Again, that's not just a blockchain thing. That's how secure are you as an organization, your enterprise systems, your staff, your physical facilities, et cetera. So privacy, blockchain is really a double-edged sword, right? I mean, there's confidentiality risks when you put that data on blockchain, because it's going outside of your internal firewall. Another reason to be frugal, right? But there's privacy risk, but there's wonderful opportunities to improve privacy. And the gentleman in the middle there highlighted one of them is, empowering data subjects with their privacy in ways that have not been possible before, with like self-sovereign identity, decentralized identity. We see use cases in healthcare for patients being able to opt in to clinical trials and control the access of their data, to review who's got permission to access, who has actually accessed, grant consent or opt in or revoke consent or opt out at any point. So it puts the data subject in control, and that's wonderful from a privacy standpoint. So they can get the transparency throughout the life cycle, from collection, storage, use, disclosure, and disposal of data.
What you didn't say very much now until now is that, of course, I can also only put a hash of data on the blockchain, right? So
You can. I mean, that's a common use case, but there's a variation in the types of data you can put on blockchain, depending on the use case. So to your point, a lot of times if you want to protect the integrity of data, even data that could exist off of the blockchain, you'll just put a hash of that data on blockchain, and the hash is pretty benign if it gets breached, right? But you could put metadata on the blockchain, right? And so in healthcare, one of the issues we talked about this use case where every doctor you go to, you have to fill out the forms again. Well, one opportunity is to put metadata on the blockchain. So if you go to one doctor and you get an x-ray, it's not that they're going to put the x-ray on blockchain. There's performance reasons why you wouldn't want to do that. There's privacy, security, compliance reasons you wouldn't want to put the actual x-ray on blockchain. But you could put some metadata on the blockchain saying, an x-ray was taken for this patient, not a social security number identifying, but some opaque identifier that somehow can be resolved in that consortium to a patient. An x-ray was taken of this patient on this date, it was torso, whatever metadata. And then you go to another provider, another doctor at some point in the future, and they can look up on the blockchain, like, what do we know about this patient, right? And they can see, oh, an x-ray was taken on this day, is this sort of region, that's interesting, we need that to treat this patient, let's go get that x-ray, right? And so also there could be a pointer in that metadata saying, if you need this x-ray, go back to this other doctor. And there could be a hash code on the blockchain as well, to your point, which is when you get that x-ray, check its integrity against this hash code, right? So yeah, absolutely.
you can add cancer cells or remove
Sure.
cancer cells from an X-ray and stuff, right?
Sure.
Or an MRI or whatever it was.
Yep. Yeah, so hash codes are a powerful tool to protect the integrity of data both on and off the blockchain. But blockchain it's really like a blank canvas. I mean, you can put lots of different data on blockchain. It's really like a chain of canvases. And so one of the things you need to decide is what data will you put on? Again, minimal but sufficient given your use case. And then the other thing you need to decide is what format are you putting it on the blockchain? Because there's, is it XML, is it JSON, is it, that in healthcare we have lots of interoperability standards like FHIR, FHIR, some of you in healthcare might know that, or HL7. But you got to think about, not just what data you're putting on blockchain, but what format. And you have to have a standard format, because if everybody puts data in different formats, well, it's not very useful for the network. It can't make sense of what's what, right? Okay, so compliance, we haven't talked about this a whole lot, but we did talk about the strategy of keeping personally identifiable information, things like protected healthcare information or sensitive IP off of the blockchain. There's actually compliance reasons for this as well. So those of you that have heard about GDPR, there's rules in there like a patient or a data subject has the right to be forgotten. So if they call up your enterprise and say, I want you to delete my data, you can't say, oh, I'm sorry, we put it on the blockchain, it's immutable, we can't delete it, right? That's another reason to keep the PII off of the blockchain, keep it in the enterprise systems, and reference them from the blockchain. So use an opaque, meaningless identifier on the blockchain, but to resolve that to the actual PII, that's in the enterprise systems, and those can be deleted. And so if that request to be forgotten comes in, they can delete that data in the secure enterprise systems. It essentially de-identifies what's on the blockchain, and you can comply. The other thing to think about with blockchain is every time somebody stands up a node, the data is going to move. It's going to be copied over to a new shared ledger under the new node, right? And sometimes if those nodes are being stood up across jurisdictions, like let's say a blockchain starts in Europe, let's say it starts in Germany, and Germany's super strong in terms of data protection and privacy, but later the organization, the consortium decides, hey, let's stand up a node in the US. Well, what's going to happen is all the data on that blockchain from day one in that shared ledger is going to be copied to the US. And you end up with this potential data sovereignty and trans-border data flow type issue. And there's adequacy complications, like is the security of the target country adequate? Well, this was the whole reason for safe harbor and things like that, to ensure adequacy of security across jurisdictions. But again, you can mitigate a lot of this risk by being frugal about what you put on blockchain. Keep the PII off if you can. So interoperability and integration, we talked about those briefly, but in short, blockchain coexists with enterprise systems. It has to be integrated. Your enterprise systems have to be integrated to the blockchain where it makes business sense. And you need to think about what format you put data onto the blockchain. That's what interoperability is. But again, think of blockchain as this sort of cog in the big machine, but a lot of times the blockchain will facilitate the discovery of data, like the metadata example. But blockchain doesn't have to be used to actually convey the data. So once organization, the second doctor discovers, hey, there's this X-ray, I need to get that X-ray. That doesn't need to go through the blockchain, and you don't want it to go through the blockchain. It can go secure, direct, peer-to-peer. The role of the blockchain is facilitating the discovery and the request. Go ahead, question.
I'm curious, I agree with you on the point of keeping as much off of chain
as you can.
Possible.
Yep.
But then you use the example of 80% of some computations for healthcare could be done on chain.
Potentially, it's, yeah.
Yes. So could you elaborate on the use case of doing the computation on chain versus siloing the computation and then just putting the hash on as a option?
Like why you would do that? Why you would do it on chain versus off?
Yeah.
So let's say, yeah, so let's say that you're, like one of the common use cases in healthcare is pre-authorization. So let's say you're going to go for an expensive medical treatment. You want to make sure with your healthcare insurance company that that's going to be paid if you do it, not discover later, oh, sorry, we're not going to cover that. So you do what's called a pre-authorization. And today those pre-authorizations go from the provider, the doctor, to the insurance company, and they're transferred back. There's certain formats without blockchain. And then if you introduce blockchain, those connections can be made through the blockchain, and the data can be exchanged, the request and the response. But a sort of layer one use case would be send a pre-auth request on the blockchain. The payer picks it up and says, okay, I got to process that. They process it in the big enterprise system that does claims adjudication or pre-auths. And they put the result back on the blockchain and the provider sees it. Okay, the answer is we'll pay for it.
Okay, I didn't know if you were saying actually do that computation, that enterprise computation on chain.
Let me elaborate. So that's like a layer one. Remember I showed you a layer in the beginning? That's like a layer one use case. Blockchain just conveying the data and the request and the response. But if you find that it's hypothetical, right? But let's say 80% of authorizations are trivial in terms of logic in that payer system. Okay, there's some very complex ones and you can't put those on blockchain. It's just, they don't want to. Maybe it's intellectual property. But let's say 80% of them are trivial and you could just put those on blockchain. And when you put smart contracts on blockchain, then as soon as the provider says to the blockchain, here's this pre-auth, if that node has that smart contract, it can actually run it right then and there and give them an instant answer. Versus if they send the request on blockchain and that payer's offline or they're backlogged with data, it could take them days to put the response back on blockchain versus if it's a smart contract, it happens instantaneously, right? So there's speed advantages, there's efficiency advantages, there's reliability advantages because you no longer depend on that single point of failure, that enterprise system on the other side of the blockchain. Does that make sense? Okay. So one of the side effects of being minimal but sufficient with what data you put on blockchain is it kind of limits what kind of smart contracts you can do, because smart contracts can only work with the data that they see on the blockchain, right? So a smart contract kind of gets triggered by certain type of data appearing on the blockchain, like it sees a request for an authorization, it gets triggered, it gets invoked, if you will. It's looking to see, like, what do I know and can I make this decision? It can only see what's on the blockchain, right? So if you're being very frugal about what you put on blockchain, it kind of limits the kind of richness of smart contracts you can do. But over time, as blockchain proves itself with one use case, as more use cases are stacked on top, the richness of data on the blockchain will increase. The scope of the kinds of smart contracts you can do on that blockchain will increase, and it'll take off. But smart contracts, that's why they're layer 2. It's going to take time for that data to get on and be useful. So performance, we talked about that briefly. Performance is one of the things you want to think about early with your use case is what performance do I need in transactions per second? And is the blockchain up to that, right? Like if I need millions of transactions a second, it may not be the best use case for a blockchain. I mean, you can do batching of transactions and that kind of thing, but there's trade-offs of latency versus throughput. So think about performance, and the other dimension to performance is you don't want to put heavy data on the blockchain. Like in healthcare, we have genomic data which can run into hundreds of gigabytes per patient. We've got huge images like high-resolution CAT scans or MRIs, and you don't want to be putting that kind of data on blockchain because it's even, privacy, compliance, and security issues aside, that data is super heavy, and if you put it on one node of the blockchain in the shared ledger, it needs to be replicated to all the other shared ledgers, right? So for performance reasons, you want to keep that heavy data off and think about throughput early because not all use cases lend themselves well to blockchain. In general, blockchain is good at use cases that span a consortium and where there's fairly lightweight data and where there's fairly stable data. Because one of the things we didn't talk about is if I put data on the blockchain and it needs to be changed, how do I do that if it's immutable, right? Well, the answer is you could put an updated record on the blockchain appended on, and that updated one supersedes the original. The problem is if you have data that's changing on a minute by minute or daily basis, you're posting new stuff to that blockchain like every day just to update it, right? And your blockchain grows and grows every time you do that. So generally, blockchain lends itself better to stable data that doesn't change too frequently. Data that's very volatile results in a very chatty blockchain, and you'll end up saturating all of your throughput and your bandwidth with just changes, not new data coming in. So think about the stability of data as well. So we talked about how consortiums are key to success with blockchain, defining your consortium, engaging them, getting to a pilot, and then getting to the case study where you can get the consortium to attest to the business value. And that's your foothold to scale. Scale in terms of the size of your consortium, scale in terms of new use cases you can add on. Those are really key points I hope you'll take back with you. Now, a little bit more on the blockchain, sort of what we're seeing, and this is not blockchain religion. None of what I gave you today is blockchain religion. It's really where the rubber meets the road based on what I'm seeing in my day job and, as chair of the HIMSS blockchain task force and so on. But what we're seeing is sort of this blockchain island phenomenon happening now where the different use cases, the different consortia, they're all doing their private blockchains, and so you have these private blockchain islands. But over time we see, that some of them will get to pilot, some of them will get to case study. Those ones that show the value with respectable consortium members will scale, and the island will grow. And those that don't get there will be selected out, right? There's a kind of a diversification happening. There's going to be a natural selection. It's starting to happen in healthcare. And the ones that are selected because they showed business value will grow. And what we'll see on the spectrum between private and extreme sort of fragmentation blockchain islands towards public is the bigger those islands grow, we start moving towards public blockchain on the spectrum over time is one way we're looking at it. It's going to be gradual, right? So I don't know how we're doing. I guess we went a little bit over, but one of the things I want to encourage, if you'd like to connect, I post a lot on LinkedIn and Twitter, Bruce knows. And this field changes rapidly, especially where blockchain meets AI and that kind of thing. So if you'd like to connect with me, I actually mixed up those icons. the email should be the Twitter one is yeah. So anyway, Twitter's at the bottom. Go ahead and reach out to me on Twitter or LinkedIn or email me. Be happy to take any additional questions. But I think we have a little bit of time now. Marissa, is that correct? Okay. Any other questions? Was there anything you were hoping to hear today that I didn't get to?
I have a question.
Go ahead.
I know we've been reading about all these use cases, but is there any quantifiable measure from any of these, like, okay, $100 million saved or whatever? So we keep hearing just qualitative
Yes.
outputs,
Yeah.
but no numbers.
Who's quantified it? Yeah. And I would say, healthcare isn't there yet, just to be totally candid and transparent with you. Healthcare is not necessarily the forerunner in blockchain. Financial services started to embrace it sooner. Does anybody else have quantifiable data from the business value of blockchain, like dollars saved? But, happy to connect if you want and can get you that when we do see it in healthcare. Just this week, we saw a very respected healthcare organization called Intermountain Healthcare stand up and say, hey, we're already using blockchain in production across 22 hospitals. It's improving patient outcomes, it's reducing costs. These kind of attestations are huge, right? And I don't think they actually quantified it in dollars, but it's very significant. I mean, it's significant enough that they're investing in it. Yeah. Yeah.
So,
sorry, go ahead. Yeah.
One thing you mentioned was that you are seeing that the enterprises start on a private blockchain and seem to gravitate from there on towards the public blockchain.
Towards, like the size of the consortium.
Yes. Yeah. So are there any real examples where you're seeing that happen?
Absolutely. Like if you in healthcare, one of the ones that is closely followed is a group called the Synaptic Healthcare Alliance. And that's Optum, United Health Group, that's Humana, that's, I think Aetna's in that group now, but Quest Diagnostics, you guys probably know from lab visits and so on. Multiplan, Ascension Health, et cetera. So that pilot, they're piloting a use case called Provider Directory. And it's provider directory information that's maintained today independently by providers and payers. And so blockchain can be used to do that collectively, right, and cut costs, et cetera. But they started off, their strategy was minimum viable networks. So they very intentionally limited the number of participants in their phase 1 pilot. They said, okay, we've got 3, they're all highly respected. We don't need 50 to show this, right? And so you want to keep that consortium manageable, because one of the things you run into with a big, huge consortium is it's hard to get agreement, it's hard to govern. So keep your network viable initially, and then, but what we saw to your question is, once they proved out their phase 1 pilot, they started letting more and more organizations join in. But one of the key things we didn't get to talk about a whole lot here is governance. Governance of the consortium is a non-trivial thing that you need to start thinking about as you're getting towards production. That consortium's growing. How do you govern it? Like if you're going to add a new use case, getting consensus. If you're going to change a certain format or add a certain smart contract, how do you get consensus across that? Like how do you manage the blockchain? I mean, we're seeing some of this with big networks like Ethereum already. Some of it's forking because they can't reach consensus, right? Not consensus in the blockchain sort of protocol sense, but consensus as far as the stakeholders. So yeah, good question. Sorry, there was another one there, yeah?
You touched briefly on supply chain and
Yeah.
specifically use cases in food.
Yeah.
I was wondering if you see, obviously larger companies like Walmart have made big steps in this. If you see the ability for smaller companies or specifically lower margin distribution companies that have, sourcing location or quality or, some of the things you're talking about, like whether it's organic or exactly where it's sourced came from, if you see ways for those businesses to get into this technology without making a huge infrastructure investment.
I think there will be.
Yeah.
Candidly, I can't speak to the status of that particular pilot that Walmart was driving. They announced it in January, though, and I believe it's still ongoing. When they get to production, and there's others in the works as well, but once they get to production and they open it up, okay, anybody can join, here's the rules, right? Either you got to pay a license fee or, here's how to connect, et cetera. There will be opportunities for all kinds of players in the supply chain. And one of the wonderful opportunities there is quality control. So organizations that plug in and they get hold of, let's say it's a spinach supply chain and they get hold of spinach. Today, if there's an assertion this is organic, you kind of have to take it at face value, right? But what if you had an organization in that supply chain that could access the blockchain, they could go buy spinach anywhere, and they could test it. Does this have pesticide? Does it have herbicide? Is it really organic? Can I prove that it actually came from an organic farm? And and then they can publish the results on blockchain. And because I think there's a lot of fraud there's a huge amount of fraud in the healthcare system with counterfeit drugs and stuff. There's a huge amount of fraud in the food industry as well, with people asserting stuff is organic, it's not. And and so players like that can do quality control or add other value and make that known to the broader network. There's wonderful opportunities both for them to add value and to improve the supply chain in terms of quality. Yeah, great question. Yeah, go ahead.
Yeah, you mentioned that consortiums, when they start out, they're almost like an island with their private blockchain.
Yep.
And as they grow, I'm just curious about what you see in the future, because there's a lot of time and effort that needs to go behind these projects. It's sort of like all eggs are in one basket. So is there like one solution that's going to be the winner takes all, or is there an interoperability solution that we're going to have to focus on? How are different ecosystems or environments supposed to communicate eventually when you get to that size?
Yeah, really interesting question. So if let's say there's two islands and at some point they've both been successful, but it makes sense for them to merge, but one's using Hyperledger Fabric and the other one's using R3 Corda, how do you make them work together, right? And I don't know how that's going to pan out. I mean, it is possible to make integration points. It's hard to ensure consensus and all of the reliability and so forth if you have a single point of failure that's integrating the islands. So I think in the near term, probably what we'll see is you can have a heterogeneous deployment architecture where you can put blockchain nodes, some on-prem, some in the cloud, and even different clouds. But within a given blockchain network, all of the nodes have to speak the same consensus protocol, right? So the nodes, in order to negotiate, like how did the shared ledger change or what's valid, and be able to maintain the consistency and validity of the shared ledgers, they all have to speak the same language. They could be implemented with different stacks. One might be C#, the other one Python or something, right? But they all have to speak the same protocol for consensus. I do know initiatives to like I think the NHS was exploring this, is they had extreme requirements for to be vendor neutral, so they didn't want to be locked into one sort of blockchain platform. So I don't know the status, but they were working on how could we facilitate even different choices of a blockchain platform working together. But you start to compromise on some of the values of blockchain in terms of reliability and immutability and that stuff if you don't actually have a fully baked consensus algorithm, if you have those single points of failure integrating two disparate islands. Yeah, that's my take on it. We might see it evolve some other way or some magical way to bridge them come up. I'm not aware of that happening yet. Okay. Yeah, another question at the back.
Yeah. So how long do you think it will take for widespread adoption of the blockchain? Not necessarily in healthcare industry. And do you think they will move from the private to public chains eventually?
Yeah, interesting questions. So,
Can you repeat it?
yeah, the questions were, how long will it take for blockchain to get mass adoption or be transformational? And it's going to vary by industry, right? And I think healthcare is about 5 to 10 years out. There was actually, there's a Gartner hype cycle that I published on my Twitter and my LinkedIn just a couple of days ago. If you guys connect to me, you can see it in my feed there. But it basically shows every industry and what the time horizon is for transformational impact. Not like one or two consortia doing it, but impact across the whole industry. For healthcare, I think they said it's going to take 5 to 10 years. But I think some are further ahead, like financial services, probably 2 to 3 years maybe. I think right now what we're seeing, certainly in highly regulated industries, is a lot of piloting going on, and some will be eliminated, I think, as a trajectory I see. But it will vary across industries. Was there more to your question? I feel like I only answered part of it.
Yeah, and do you think they will move from private chains to public?
Oh, yes, thank you. So will they move from private blockchain to public blockchain? I think it's going to vary by use case. Like some use cases lend themselves really well to public blockchain, like even just within healthcare where you'd think there isn't really a good one because healthcare data is so sensitive. If it's information on like, public health, like it's anonymized. It's not, you're not putting any particular patient information on the blockchain, but you're publishing, hey, there were 3 cases of Ebola in this state, right? That's a kind of information. A public health type use case, even in healthcare, could find its way onto public blockchain sooner. There's also some hybrids where we see, for example, the health information exchange use case we talked about, where you could put metadata on the blockchain and track provenance of data and that kind of thing. There's at least one initiative I know of in Europe that is doing health information exchange for clinical trials, and they're using 2 different blockchains. They're using Hyperledger Fabric for information, like health information, metadata, and provenance, and they're using Ethereum for cryptocurrencies and crypto tokens. And they're using both of them under the hood. The Ethereum one is to reward patients for opting in and participating. And so they get crypto tokens, and they can then go redeem those for reduced cost of healthcare, whatever the value is. So sometimes it's not either or, it's both. Like in some use cases, you might see both a private and a public blockchain for different reasons. It's really back to the use case. And
About industries
Sure.
today, right? But I still can't believe why we don't really have true alternatives to social networks, voice over IP communications. I mean, all this existing stuff is broken.
Yes.
Yeah.
Yeah. Yeah, I mean,
You
it's,
you
yeah.
could make that. You could really reinvent that on a public blockchain, right? You could reinvent the social network on a public blockchain.
Yep.
And I think now with regulators going after Facebook and so on, and people becoming a bit more aware maybe about the value of their data and so on,
Yep.
there should be a lot of reasons why people, once we have a real alternative, should jump on that, right?
Yes, absolutely.
And then that would also like really spread quickly, potentially, right? Just like.
And so if we look on the spectrum of like the transformational impact, I mean, it could vary in terms of the amount of impact. It just kind of depends on the uptake. And the scenario you're painting out is an extreme transformation. I mean, it could turn the internet upside down. Today we have a lot of big social media companies and other companies that are collecting a lot of data, and they've got massive troves of data, right? What if you turn that on its head so that data remains decentralized and there is no single point of hoarding data? There's huge privacy reasons why that would be a good thing, and and mitigating risk of hacking, right? If you have a huge database in one place, it becomes a sort of huge attractor for hacking and breaches. For file storage, right? You could potentially decentralize that on blockchain, right? Anybody could put their computer online and say, okay, you can use a terabyte of this for decentralized blockchain-based file storage, and whoever wants file storage, just do it through this blockchain, and you could do compute sharing like that. You could do Uber type things. Any kind of gig economy, sharing economy type thing could find its way there. Or even social media, even YouTube. There's DTube, I think, is a decentralized version which does videos. So
Because whoever got paid by posting a YouTube video.
yes, I used to be. They revoked that, yeah. They stopped paying, yeah.
Yeah, it's also like this trust, like a lot of companies, like even German automakers, for example, right?
Yep.
When you talk to them, like, this trust thing, they have like a hard time realizing why this trust thing and immutability is such a big deal, right?
Yeah.
But in every industry, right, there is fraud happening big
Right.
time.
Yes.
So they don't see the need for such infrastructure in many ways, which is funny.
Yes.
And like when you look at how many views do you have, you think about online advertising, right? I mean, who controls those results? Yeah.
Yep.
We have to make that transparent. Yeah.
I think it's highly likely that in the longer term, some of the transformational impact you outline will happen. But I think, just candidly right now, I think a lot of the industry and general consumer base is going through a bit of a trough of disillusionment with blockchain. 3 years ago it was like, huge, right? And everybody was talking about it. Bitcoin was at like $20,000, and it's bounced around since then, and blockchain's lost some of its gloss. So in the point where we are in the trough of disillusionment, I think it's super important that anything we do with blockchain, we're not doing because of blockchain, we're doing because it delivers value. right? It delivers value to patients or to organizations, or once we get through that and it proves itself, and again, the low-hanging fruit is existing use cases, existing consortia, drop blockchain in, proves itself out, and then you've got a solid foothold to grow into some of these transformational use cases. What we don't want to do, or we don't recommend doing, is if you go in and preach, this is going to turn your world upside down, start doing it now or you're going to be disrupted. It's not a good recipe for success in our experience. It's better to focus on the business value, at least for the enterprise consortium use cases. You might have a consumer-facing use case, like upload your video here because you can monetize it, not there. Maybe that will succeed, I don't know. But focus on the value, I think, is the key thread. Yeah. Interesting, yeah. How are we doing for time, Marissa? We're almost at 6. One more question? Anything else we missed that you guys were hoping to hit? We've covered a lot, but... And if you think of something later, just reach out to me on LinkedIn, on email, whatever. And if you guys want the slide deck, so I think they recorded this whole session. They have a copy of the slides. I think they'll post it with the video. If you want to share this with anybody, please do so, and you can download the slides. Always welcome feedback if you think there's ways we can improve it. Thank you very much.